Hi, everyone. I just wanted to do an extra help follow-up video regarding this sheet, which was the acid-base neutralization reaction. Many of you did not balance these equations. Either you didn't attempt it or you didn't do it at all. So I would like to refresh you and redo some of these equations. So the first one that I'm going to look at is number 1. HCl, hydrochloric acid, plus sodium hydroxide, which is a base. An acid plus a base will neutralize. It's a salt plus water. So we have to put the charges in. H has to be +1. Cl is written second. It has to be negative. Sodium is positive. Hydroxide is negative. Remember, these are all in AQ. Many of you did a really good job with why acids, bases, and salts are electrolytes. This will double replace. So the H goes with the OH minus. So the Na positive goes with the Cl. It's a double replacement ion switch. Na positive, Cl negative. 1 electron lost, 1 electron gained. Finished. Done. Formula is correctly balanced. And then this is H plus and OH minus. So this was an acid plus a base is a salt plus water. This is a salt, metal plus a nonmetal, ionic. And this is completely balanced, which tells us the number of ions on this side is equal to the number of ions on that side. So in that sheet, just so that you know, the HCl and the NaOH became NaCl plus HOH. It was a simple double replacement. Now, I'm going to jump right down to number 3. This answer here was just the same thing. It was HCl plus sodium hydroxide becomes sodium chloride plus H2O. So that was just a fill-in. But let's look at this reaction. H2SO4, which is sulfuric acid, reacting with NH4OH, ammonium hydroxide. Okay. Again, it's an acid plus a base. Again, we have to realize that the SO4 is a polyatomic ion. So this has to be +1. This has to be -2. That refers to the short answer question. Why is it important to check the charges? We need to know the charges in order to write the equations correctly. So now this is going to work with NH4 positive and OH minus negative. Without the proper charges, you're not going to be able to write the salt and the water. So acid plus a base is a salt plus water. The H will recombine with the OH, and the NH4 will go with the SO4 -2. So let's write the salt first. NH4 positive goes with SO4 -2. This is a positive and this is a negative. This is a salt. So ammonium sulfate would be the answer or the name. But you can't lose 1 and gain 2. So we have to write this formula correctly. So we need a subscript of 2 down there to get this to balance out. And then this is understood to be a 1. That's that crisscross that goes all the way back to September, balancing the charges. Now, what's left? H plus and OH minus. Excuse me, has to be. But now we have to balance. So you have 2 H's on this side. So let's try it. If we put a coefficient of 2 in front of there, that now gives me 2 H's on this side. But remember, the consequence of the coefficient is that it distributes. So now there's 2 hydroxides. All right, so we need to clean that up. So if we put a coefficient of 2 in front of there, now we have 2 hydroxides. We also now have 2 ammoniums. But that's a good thing because there are 2 ammoniums in this formula. So it's done. So the coefficients are 1 to 2 to 1 to 2. Now that equation is completely balanced. Now, the last one I want to do as a follow-up to this sheet is H3PO4 plus CaOH taken twice. Acid, base. Now, let's not forget, we can always use the reference tables to look at these. But isn't it true we should put the charges in first? This is a plus, and this PO4 is a -3. You could get that by reverse crisscross. Or you can get it, and let me just reach over here. You can get it because of table E. Table E has the polyatomic ions. And if you look at the PO4, which is the phosphate, it's a -3 charge. So remember, these polyatomic ions, they react as a unit, keep them as a unit. They have an overall charge. Acid, base. Let's assign the charges to the calcium. Calcium can only be +2 from now until the end of time. Calcium, remember, is in group 2 of the periodic table. Alkaline metals, alkaline earth will lose 2 electrons. That's what it does. So it can only be a +2. No stock system necessary here. Now we have the acid, we have the base. Let's do the double replace. We see the H is going to go with the OH, and we see the calcium is going to go with the phosphate. So calcium is the +2, phosphate is the -3. Not allowed. Can't lose 2 and gain 3. So we need the 3 down there, and we need the 2 over there. Plus H plus OH minus. So the question is, okay, now I have to balance this. This is calcium phosphate. That's a salt. A metal plus a polyatomic. That has both types of bonding in it, by the way. Ionic between, but covalent within the polyatomic. So here we go. I have 3 calciums over here. That's got to be fixed. It's got to be. So I'll put a coefficient of 3 there. So 3, 3. But what did this coefficient of 3 do to the hydroxides? 3 times 2. That's 6 of them. All right, let's go for it. If I put a coefficient of 6 there, that helps my hydroxides. But now I have 6 H pluses. Gotta make it work. No big deal. I have 3. I need 6. 2 times 3 is 6. So that's a good deal. 2 phosphates. That's okay, because look, the subscript of 2 is here. That's usually where students lose it. If they don't write the salt correctly, they can't balance. So 2 times 3 is 6 H pluses, 6 H plus. 3 calcium ions, 3 calcium ions, written in the formula. 3 times 2, 6 hydroxides, 6 hydroxides. So now, based on the law of conservation of matter and energy, the equation is balanced. Based on acid-base neutralization, the equation is balanced. An acid plus a base is a salt plus water. This is common, important chemistry as we continue our class. So I hope that follow-up helps. I would strongly recommend that you redo the acid and base neutralization reaction worksheet, and we will continue from there. We're going to start a new unit called nuclear chemistry soon enough, but we can't leave this behind with such a misconception. Many of you did not do those equations correctly. So I wanted to follow up, and we'll move forward from there. Have a good holiday for those of you who are celebrating, and I appreciate all that you're doing in your Google Classroom. Talk soon.